Hi everyone, I'm Max. I'm a .NET developer from New Zealand. On my spare time, I develop open source monitoring solution for SCOM platform and write some articles in my blog. Unfortunately, not as often as I wish. In one of my articles, I wrote that I believe that SCOM can be a kind of microservice platform for all type of automations. And today I'm going to reveal one of its secret feature, which can make a solution more universal and allow you to leverage SCOM platform not just for monitoring. In particular, I'm talking about an ability to upload any files from SCOM agent to management servers. It may be not exciting for a corporate environment with highly connected networks and trusts between all servers or machines, but collecting files from remote nodes might be an issue when infrastructure it's not heterogeneous. Not consistent with all nodes. So some nodes may be in public clouds, some have nothing but public internet connection, some may be not Active Directory domain joined, not trust, firewall issues, etc., etc. In this case, if all the nodes are covered with SCOM agent, SCOM itself can provide a secure upload channel with end-to-end encryption. So in today's session, we'll take a look at a few possible scenarios on how to use the file upload feature. Then I will explain the feature itself and how to use it. We'll review some demo code. Unfortunately, due to some technical reasons, there will be no live interactive demo. However, I hope it's not a big issue as the nature of the demo project itself is not entirely interactive. But I'll demonstrate some screenshots with created SCOM rules and with project results files it brought back. So let's talk about a few ideas. Why would you need to send large files from SCOM agents back to management servers? The most obvious use case is log shipping. And despite there is a large variety of specialized tools like Splunk, QRadar, you name it, it may be useful to have a small, low maintenance solution based on existing SCOM infrastructure. And advantage here, you don't need to open any additional firewall ports to install any additional agents. What you need is just to install a management pack, do some settings, and you'll get your logs shipped into central location where you can process them, even uploading into one of those solutions, but you can save some infrastructure costs or deployment costs. Other scenarios may include uploading results of running external process. For instance, you have a third-party software which collects some information about each of your machine. Say you're preparing to migrate into cloud and you run some specific tools which assess your virtual machines, collect information, save them into local files, and then you need to collect all those local files with collected information in a central location. So this is also a possible scenario for that feature. Another possibility is quite exotic, and that can be a custom discovery. So say, for instance, you need a snapshot discovery, but number of discovered objects is extremely large. If you go into traditional SCOM way, creating discovery data item, it can exceed SCOM agent data item limit, or when management server inserts all the data into SCOM database, database may even become not responsive for a certain time, and that can hugely affect SCOM performance. So you would like to have something incremental, something staged discovery, but it's not possible with traditional ways. So that scenario, as I said, is quite exotic, but you can collect information, inventory information about your future SCOM instances, send it as a file into central location onto management servers, and here have like offloading process, which can leverage connector framework and do incremental discovery because it will have access to SCOM inventory, to SCOM class instances, and it knows what is already here. Although this is not really a subject of that session, but you may consider that possibility. Additionally, you can even create something like remote file explorer and download it. So imagine you have a couple of agent tasks which return files in current folder and can change folder. And then another task, another agent task, which initiate a file download. So you even can create a UI in SCOM console, which allows you to browse a remote machine disk and select a file to download, and it will bring it for you. Now let's have a look how we can implement that feature. So if you find one of the scenarios we looked previously useful for you, or you have your own use case, there are two SCOM workflows in the standard library, which always present in any SCOM installation, which are literally a sender and a receiver. So you have system.fileUpload write action, which is a sender. So you can pass a file name into that write action, and it will upload your file. And then you have system.fileUpload data source, which is literally a receiver. And each time something has uploaded a file, that data source will send a data item signaling that, hey, a file is arrived and you need to process it. But the problem with using to those modules, write action and data source, is significant lack of information. Literally, there is no documentation on them. So you would need to run a few experiments to figure out how they work. Luckily, in this presentation, I'm going to pull a cover and provide some working example and explain how you can set up those modules and use them into your projects. So first of all, let's look at modules configuration. What parameters you need to pass when you're using those modules in your custom rules. So first, file upload write action requires you destination manage type ID, which is in this scenario will be central management collection server, and this is literally to which machines or to which agents which manages those classes will be uploading files. So we'll see it a little bit later. It might be more clear. Upload channel ID is just a unique identifier. So in my test project, I use just a GUID, although more convenient way would be using one of your management pack element and provide GUID of that element just for some consistency. Although you can generate any GUID and put it in here just to make certain that channel is yours. And finally, and the most interesting is source file path is simply a full path to a file which you require to upload. And then second module, which is file upload data source. It requires for its configuration just a channel ID. So you put this absolutely same ID to say, hey, this is my channel. I'm using the channel. Please notify me on any uploads inside the channel. And this data source, file upload data source, will send a data item each time a file in this channel is received. The data item will have two fields. File path, which is a full path to uploaded file. It will be a random name in a temporary folder. And an original file name, which is the file name which you send to upload write action. Because file name also can have some useful information, and so you may wish to parse it. So far, I hope it sounds pretty straightforward. But are there any tricks? Yeah, there wouldn't be any if I didn't ask, of course. And there are a few concerns. So first of all, since we create files and upload them, we may wish to delete uploaded files to avoid any disk overflow. Same with when we're receiving files. So to avoid temporary location overflow, we may wish to delete those files. How we can achieve that and what is trick is here. So when we send a file, that should be a responsibility of our code to delete a file after upload is completed. However, we need a certain way how we know when upload is completed. Because if we delete it before upload is completed, upload will fail. On contrary, when we receive a file, then file upload data source, or SCOM itself, you can consider it like that, is responsible to delete the downloaded file, but not before our code or our workflow has proceeded this file. So we need a way how to signal that we completed our job with the file and file can be deleted. So, and this is the main trick. How do code knows that upload is completed or processing is completed, right? And the answer to that is pretty rarely used confirm delivery flag in a rule. This flag causes SCOM agent don't stop processing a rule transaction until all member modules which requested acknowledgement callback finally receives it. This flag is optional for our upload rule. If an upload rule, we don't need to delete the file if it's a static file, but it's compulsory for downloading rule. SCOM must delete the downloaded file to avoid temporary location overflow. So let's have a look how upload rule work. Let's have a look how workflow flows from SCOM code to our code to standard action to our actions. And one of the things, because we need to receive acknowledgement callbacks, unfortunately our actions can only be written in .NET in C#. If you use PowerShell or JScript or VBScript, those type of actions are unable to receive acknowledgement callback. So you have to implement your portion of the rule in managed code in C#. So in that example, at SCOM site, we have an instance of simple scheduler data source, which simply triggers every 240 seconds, initiating the rule to run. Then this data item, trigger data item, sent to our code, where we collect events, we save them into zip file, then create a property bag with the file name and success flag. Then we have standard expression filter, which evaluates if log collection was successful. If it will stop if not, but if it's successful, then it simply allows data item pass through, and data item will be sent into file upload write action. And the file upload write action will take full path of the file we created and will start uploading it. When upload is completed, it will send a callback, which will land again in our code. And it will be using onAcknowledgement callback method. So write action from SCOM will call our callback method, passing the variable which we supply when request callback, which we use as a file name, and hence in our callback action we can delete that file. When the file is deleted, everything is end, and we signal to SCOM agent that we are ready for next cycle by calling request next data item SCOM host method. So this is our second rule. First rule was sending files, this one receiving them, so I call it download rule. So that begins at SCOM side with file upload data source. When a file is uploaded into our channel, it generates a data item with original file name and temporary location for the downloaded file. And that data item, upon with complete callback request, is sent to our code. So we can process the file. In this example, we simply copy it into a permanent location, but you can process the file, extract information, insert it into database, or do some correlation, whatever you need for your scenario. But when this job is completed, your code must call a requested callback function, and that call will land into file upload data source again. And this is how we indicate that, hey, we completed with the file, you now can delete it. And the file upload data source will delete the file and then finalize this rule cycle. Important note, if the rule with file upload data source doesn't have confirmed delivery flag, then data source will delete the file immediately. It will send a data item to your code, and it can be, for example, PowerShell or whatever. It will send it data item here, but your code will also find the file already deleted and will throw IO error, file not found. So let's have a look at some managed code, which is coupled with those actions, with those standard SCOM modules. So this particular code is for probe action to create file for upload. This code is coupled with file upload write action. A property bag created in this code will be sent to the input of file upload write action. And then upload write action receives our property bag. It will initiate upload of the file we specify into SCOM management servers. However, this will be only half of the job. So from the code perspective, right here, I hide a code which collects those events because it's not important for subject of that session. But what is important when file is created, so zip file exists, and we have some data in this file, we generate a data item. We put okay, that yes, file is created, okay, and then we put file name. So that result path is predefined name, which upload write action will expect. If you name it somehow else, it won't be able to find the file. And finally, in this line, we not just sending our data item, but we also requiring file upload write action, which will be receiving our data item, to call us back when process of our data item is completed. And we'll see that on the next slide. So this is the callback function, which we send together with our data item. And when the upload file write action complete upload, it will call this method with the state object, which we sent as our file name, and we'll be able to cast it back to file path and delete the file. And after that, we can finish our rule lifecycle and request next data item. So on previous two slides, we've just seen how to produce a file, send it to upload write action, receive upload confirmation, and delete the file. So now that our file is traveling to central management servers in our channel ID, and we are ready to receive it. So that code on this slide is a receiver write action, which processed the received file. It's coupled with file upload data source. So when uploaded file arrives, the file upload data source, which is in fact I would call file downloaded rather than file upload, sends us a property back, which indicates an arrival of our file with original and local file names. So our code, our write action, receives that property back and processes the file. In this case, we simply copy it into a permanent location. And after we finish to process the file, it's our turn, in this case, to notify that job is completed. So in upload action, there was SCOM write action, which notifies us that upload is completed. In this case, we notify SCOM that we have finished with file processing. Okay, so when we do that, it will cause callback to file upload data source, and it will be able to delete the downloaded or uploaded file. So there are two important blocks in this code. So this simply just moves the file into another location, so that mimicking processing the file, it creates, because it collects logs from variable machines, so it creates a subfolder for each computer name, which is extracted. And here, why original name is useful, from original name, because original name has originating machine name. And finally, which is most important, when acknowledgement was requested, we made acknowledgement callback, acknowledgement and completion callback, and that would be indication to file upload data source that we have processed the file, we don't need it anymore, and it can be deleted. So as I said before, unfortunately there is no such interactive demo, but in the next few slides, I'll show some screenshots with sender and receiver rules and how delivery data from that demo project can look like. And of course, the demo project will be published on my GitHub repository, so you can download it and try in your own environment. So in this demo management pack, I defined two rules. One rule, collect events from selected Windows event logs, which can be defined in here. You can put any log names. It will look into them all. Then it collects events every few minutes, by default 240 seconds. And then that rule will save them into an archive zip file, one file per each log, and upload them. So as discussed in details previously, that rule is a chain of simple scheduler, our probe action, which we reviewed previously, that probe action prepares file with events, condition detection to purge failed attempts, and finally file upload write action, which sends file to the central location. This rule target Windows client operating system, or you can target just Windows operation system, so it will run remotely or locally at all Windows machines which controlled by your SCOM agents. And the second rule here, it runs on collection servers and it will receive our events and then simply save them into a permanent location. What you need to consider with that rule, that it can run on any management server, and therefore all management servers have to be prepared either with that folder, or in the real world, you prefer to upload files into a network location or any other centralized location, or write into the database, or process them in any other way. So this way is done for purely for demo purposes. It's not recommended for production. So those two screenshots show uploaded files at one of the management servers. As you can see, archive consists of two files. For each file for requested log as we configure it. So I configured application event log and security log. If I add any other logs, they will be saved into their respective files. And each file is simply an array or a list of XML encoded Windows events. It's a native format. When you read events from Windows log, you can request XML representation. And as just an example, the events are not really processed anyhow, but in the real world, in a real application, you might like to, as we discussed, load them into database, save into another event X file, or run some summation correlation. So you can do some extensive monitoring, correlating events from two different or multiple machines, which is not possible when you process events locally. So just to elaborate this idea, so you have a number, SCOM itself have a number of monitors which looks into event log, grab some events by condition, or you can make more sophisticated rules which count event in certain interval. But the problem here, they will be only processing events on that machine where your rule is running, because they will run locally. If you deliver events into central location, you can have much more sophisticated scenarios when you process events from multiple machines all at once, and you can do some correlation over your network. And again, it's not will replace Splunk, but if you need something based on SCOM, this is a chance you can make it fairly quickly and with no additional cost to all these expensive systems. And so what's next? So we have a look into some scenarios, how you can use that feature. We had a look at the example, and you're welcome to download that example from GitHub and run on your own management group. You can experiment, you can add more features. But all these scenarios, they considered sending from multiple locations, sending from SCOM agents to a central location. But what if we need the other way around? What if we need to deliver data to either some or all SCOM agents? What if we need to upload data to multiple locations? That will be a subject for the next experiment, and I would like to encourage you to take this and do some experiments and possibly share results and your finding. To start with that, let's have a look at the write action configuration. So it has that destination manager type, which is our scenario is set to collection management server. And it may be turned around that it actually the only allowed value for that. And this is a very special upload, download, write action, and data source, which are not really universal and doesn't accept. But curiosity never has limits, and we can try to change that value to other type, because at the end of the day, this is just an ID of a SCOM class. So in theory, any class can go here. For example, it can be system center agent, and in this case, we shall expect something delivered to all agents, for example. Or it can be local disk, so it will be delivered to all systems through local disks, or we can create our custom class, and then it will be only delivered to those agents which manage our custom class. And that's how we can control where the data is being delivered. So when we use this ID when uploading file and all targets will so one important thing here, because we uploading to all agents which manages collection management server, so we have match that manage type with our rule target, because otherwise it will be sent to instances, to agents which manage instances of that class, where our rule is not running, or the other way around. So we need matches rule target and destination type. Well, this is all for today, and I welcome you to ask any questions if you have.